Welcome to this training video about the three MEDINA components: Continuous Certification Evaluation, Risk Assessment and Optimization Framework, and Automated Lifecycle Manager. These components are part of the MEDINA framework and manage the life cycle of security certificates in an automated fashion. In this video, we will cover 4 parts. First, an overview is given about the 3 components and their roles in the MEDINA framework. Second, we will see how to use the individual components, including a short demonstration. Third, we review a few technical details, and finally, we give some pointers to further reading. We start with an overview of the components, their features, and their purpose in MEDINA. The Continuous Certification Evaluation collects assessment results and builds an evaluation tree for the target of evaluation representing the aggregated assessment results on higher levels of the certification scheme, for example for the EUCS. It has a navigable user interface that allows the user to interact with the evaluation tree. It receives the structure of the used certification scheme from the catalog of controls and metrics, which can be seen in another training video. The configurations regarding the target of evaluation are received from the orchestrator, which can also be seen in another dedicated training video. Once it has built the evaluation tree, it is sent to the Risk Assessment and Optimization Framework. Furthermore, it calculates statistics about the historical compliance of a cloud service, which are called operational effectiveness. The Risk Assessment and Optimization Framework dynamically analyzes and evaluates detected non-conformities in the evaluation tree and outputs an estimated risk. It operates in 2 modes. First, a static mode which allows a manual usage through the graphical user interface, explained in a dedicated demo. Second, a dynamic mode which works automatically and can be triggered via an API. The result is an evaluation of non-conformities in the cloud service which are identified as minor or major deviations. The results are then forwarded to the Lifecycle Manager. The Lifecycle Manager automatically generates a preliminary certificate state. To make this decision, it integrates multiple factors. First, it uses the risk value calculated by the Risk Assessment and Optimization Framework. Second, it uses the operational effectiveness values calculated by the CCE. Third, it uses timing rules that are defined in the EUCS. These rules specify, for example, that a certificate has to be withdrawn if it has resided in the suspended state for a certain time frame without remediation. The Lifecycle Manager is integrated with the orchestrator to store and modify certificates and their status, and with the SSI system, which is explained in another training video. Here, you can see the components' connections in the overall MEDINA framework. As you can see, they have multiple connections to components from other work packages. For example, the Risk Assessment and Optimization Framework obtains information from the catalog of controls and metrics. Furthermore, the Continuous Certification Evaluation obtains assessment results from the orchestrator. Further interactions are related to users who interact with the components to, for instance, view information about existing certificates and their states, or to configure the risk assessment. Let's now take a closer look at the functionalities of the individual components. The CCE aggregates assessment results for a particular target of evaluation and presents them in the form of an evaluation tree. It supports multiple such targets of evaluation for different cloud services and holds an evaluation history for each one. The input it processes include the structure of the certification scheme, including the categories and controls of the certification catalog, which is provided by the catalog of controls and metrics. Also, the orchestrator provides the CCE with information about existing targets of evaluation and the assessment results. These assessment results are aggregated and the compliance state of each tree node is calculated. The results can be viewed in the user interface. The Risk Assessment and Optimization Framework conducts a risk-based analysis and evaluation of the non-conformities that have been identified and aggregated by CCE. As inputs, it uses the targets of evaluation as well, provided by the orchestrator, and the respective evaluation tree, generated by CCE. Also, it requires the user to configure the asset and impact values through the user interface, such that the risk assessment can produce more precise results. The risk values are then compared with the ideal risk, and on this basis, it is decided whether the existing nonconformities present a minor or major deviation. This result is then forwarded to the life cycle manager. The life cycle manager takes an automated decision about the state of a certain certificate related to a target of evaluation. As inputs, it primarily uses the report by the risk assessment and optimization framework, which indicates a minor or major deviation. Also, it obtains historical compliance information from CCE, called operational effectiveness data. Finally, it also checks for certain timing rules defined in the EUCS for transitions between certificate states. The output is then a certificate status, which may be new, continued, suspended, withdrawn, updated, or renewed. In this figure, the different certificate states and their transitions are shown. They are defined as such in the EUCS. Of all the states, 4 can be considered as valid states that indicate an issued certificate: new, continued, updated, and renewed. As can be seen here, almost all states are dependent on the outcome of a periodic reassessment, which can be automated, at least to some degree. After assessment results have been sent from the orchestrator to the continuous certification evaluation, they are aggregated in the form of a tree, which can be seen in the respective user interface. The tree is built per target of evaluation and shows which resources are configured in a compliant way and how these results propagate to the level of requirements, controls, and the overall catalog. To make it more easily navigatable, certain nodes can be excluded and a zoom is available to fit the tree to the required level of detail. The tree is sent to the risk assessment and optimization framework, which calculates a risk score for the current state of compliance. To customize the risk calculation process, the respective target of evaluation can be selected, and weights for the different resource types or for specific resources can be defined according to the 3 security protection goals: confidentiality, integrity, and availability. This way, specifics of cloud services and their asset types can be considered in the risk assessment process. Finally, the risk assessment and optimization framework assigns the result to either a minor or major deviation type and sends this information to the life cycle manager. Here, the information is included in the state transition decisions, and the new certificate state is stored in the certificate state history. This certification information is stored in the orchestrator database and can be viewed via the orchestrator user interface. The certificate status links back to the respective tree that was created in the continuous certification evaluation, so the respective non-compliances can be investigated. Let's now look at some installation details of the 3 components. All components can easily be built and deployed using Docker. Further installation details are contained in the respective README files in the public MEDINA repositories. The used technologies comprise Java, Python, and Go, and use MySQL or MongoDB as databases. Let's look at further reading material in the MEDINA project. The MEDINA website contains the public deliverables, scientific publications, as well as many other useful information. Our YouTube channel comprises more videos, especially for training. The MEDINA Zenodo community and the source code repositories also hold documents and source code for further reading and development. Thank you for watching this training video. Goodbye.